Welcome all of you. This is another video in Maths Made Easy, where I'm going to take up the important questions for the board exams. Okay, these are few questions which are slightly different, and this video particularly applies for advanced maths students. Okay, so go through all the sums. Every sum, this is a mix of sums from different chapters, including trigonometric identities. You have also have here similarities. So there's a whole lot of area of segments of circles. We'll cover these topics in this particular chapter. So let's go through the sums, and probably you might find these sums useful in your exams. Okay, so let us start. Here we have cos theta plus sin theta is root 2 cos theta. We have to prove cos theta minus sin theta is root 2 sin theta. Note the change here, note the change here. Okay, so we'll start from what has been given to us. It is cos theta plus sin theta, and let us do a whole square, then root 2 cos theta. If we are squaring, we have to square both sides. Okay, so we have started with what has been provided to us. So here cos square theta plus sin square theta plus 2 sin theta cos theta is 2 cos square theta. Okay, so now what we'll do, we'll bring this one this side, and we'll take this part to the other side. So then it becomes sin square theta. Now here we have cos square theta minus 2 cos square theta will be minus 1 cos square theta. Here 1 cos square theta minus 2 cos square theta. So 1 minus 2 is a minus. Okay, and take this one to the other side. So there is a change in sign. Okay, so now what do we have? We have sin theta plus cos theta. We are using the identity a plus b, a minus b. Okay, that is minus 2 sin theta cos theta. Okay, so now we have, for sin theta plus cos theta, we are going to substitute this. Okay, so we are going to put a root 2 cos theta once again here. Okay, and then sin theta minus cos theta, and that is equal to minus 2 sin theta cos theta. Okay, so now we are going to cancel cos theta and cos theta from both sides. This minus sign will multiply with minus on both sides. Okay, once we multiply with minus on both sides, then this is going to become minus and this is going to become plus. And another thing, root 2, here root 2 and that 2, that gets cancelled and we get a root 2. Because 2 is root 2 into root 2, that is why. So here cos theta, which has become positive because we are multiplying with a minus both sides, minus sin theta. Yes, that is equal to root 2. Now this minus has gone because we have multiplied with a minus sign, root 2 sin theta. Okay, so we have got what we wanted. We have got this statement now. Okay, cos theta minus sin theta is equal to root 2 sin theta. So what is the trick involved in this sum? The trick involved is the squaring, and the trick involved is also this using of identity, also substituting the original expression here. All this is the tricks of this question. So here is a question. This is a regular pentagon of radius 5. Okay, they have given us this, and they are asking for the area of the shaded region. Okay, regular pentagon. The word regular means all these sides are going to be equal. Now they want the area of the shaded region only. Now what do we do? Here is also shaded. Okay, so if it is a regular pentagon of radius 5, remember all these sides are equal, as I said. Then if I join this, then these angles will also be equal, because they are going to be equal chords which will be subtending equal angles at the center for the same circle. Okay, they are all equal chords, they will subtend equal angles at the center for the same circle. So now let me find how much is going to be these interior angles. So therefore angle subtended by AB, that is equal to, angle subtended by AB is going to be a 360. Now note here, this full angle is a 360. We'll simply divide it by a 5. Okay, if we divide this by a 5, we get a 72 degrees. Okay, so we get a 72 degrees angle subtended by the chords. In that case, if this angle is a 72 degree now let us find this one. We can just join here. Okay, then it will be two sectors, and the sector together 72 degrees and 72 degrees is going to make a 144 degrees. Okay, so we'll just assume this to be here. So we get two complete sectors. This is one sector already, this is another sector. Therefore, area of the two sectors all together only. Okay, we are not going to do it twice. 144 by 360, this is the fraction of the, because the full circle makes pi r square, full 360 degree makes a area of pi r square. If I am taking only 144, it is going to be that fraction of pi r square. So this is pi r square, because they have asked for area. When they ask for length of the chord, when they ask for the length of the chord, then we go for, when they ask for the length of the chord, then we go for 2 pi r over there. So anyways, now we are going to solve this. We can even do it in terms of pi itself. So here 144 by 360 into pi into 25, because radius is 5. Okay, so that gives me, if I cancel with a 5, 72. Okay, so that gives me a 10 pi. Okay, so that is my answer, area of the shaded region. So in very simple method we have solved this. Now this is our next question, tan to the power 6 theta. Okay, so tan to the power 6 theta, we have to prove 6 to the power 6 is equal to tan to the power 6 plus 3 tan square theta into sec square theta plus 1. How do we prove it? Okay, so here simply we are going to take sec square theta is 1 plus tan square theta. Now we are going to cube both sides. We are going to cube both sides. So it is sec to the power, so this one we got from the identities, trigonometric identities. 6 theta is 1 plus, I am using a plus b whole cube formula, 3 a square, that is a b, plus 3 a, that is 1 b square, note the 4, plus b cube, b cube is tan to the power 6 theta. Now that gives me 1 as it is, this one, this was 1 cube, plus I'll just copy the tan to the power 6 theta. So I've got this term and this term ready. Okay, now I just have to get this. So from this one and this one, I'll take the 3 tan square theta common, 1 plus tan square theta. Okay, 1 plus tan square theta, 1 plus tan to the power 6 theta plus 3 tan square theta sec square theta. Okay, sec square theta. So that is 1 plus tan to the power 6 theta plus 3 tan square theta sec square theta. That is equal to this. So we have got the asked expression by cubing both sides. So you just have to observe the sum little bit. Okay, how can I make sec to tan? That is, this is the only formula which can convert sec to tan, because that side is all tan. And then how can I get sec to the power 6? That means if sec to the power square is cubed, I can get that 6 to the power sec to the power 6. Okay, so that is it. So sec theta plus tan theta is equal to p. Show that p square minus 1 by p square plus 1. Okay, that is equal to sin theta. Okay, so this is what we have to prove. Let's see. So here we have, this is p. Here they are saying p square. We shall square this. Okay, We'll square it and see what we can do. So if we square it and write it straight here, sec square theta plus tan square theta plus 2 sec theta tan theta, okay, minus 1. So we have started from the LHS, by, so this much is our p square here to here, and this is this minus 1. Sec square theta plus tan square theta plus 2 sec theta tan theta plus 1. Okay, denominator also written. If we have also written the denominator, now we are going to work on, let's see. This is sec square theta minus 1. Sec square theta minus 1 is a tan square theta, right? Because sec square theta is 1 plus tan square theta according to the identity. So sec square theta minus 1 is only tan square theta. So we are going to use this now in our sum. Why we are using it? Because I can see there is only one sine theta. So we have to slowly convert the entire thing to just one variable here. So now sec square theta is 1 plus tan square theta plus tan square theta minus 2 sec theta tan theta minus 1. Now for the denominator, what we'll do? We will take this one and we'll convert it to sec square theta. So what we get now is this sec square theta as usual to be written, this one plus this one, another sec square theta plus 2 sec theta tan theta, okay. Then this is 2 tan square theta plus 2 sec theta tan theta by 2 sec square theta plus 2 sec theta tan theta. That is, now we can take the 2 tan theta outside. So we will take 2 tan theta outside the bracket, tan theta plus sec theta, okay, because 2 tan theta has been taken common, and now here we will take 2 sec theta outside the bracket, that is sec theta plus tan theta, okay. Now cancel these. So tan theta by sec theta is a sine by cos. This becomes, tan becomes a sine theta by cos theta into sec theta, this sec theta, okay. Cos and sec when multiplied give you a 1, that is equal to sine theta, that is equal to sine theta, which is the RHS. Hence we have proved it that p square minus 1 by p square plus 1 is equal to sine theta. We started from the left hand side, we reached the RHS by using actually a plus b whole square. Okay, that is what practically we have used here, and little bit of factorization we have done at the end to cancel out things, okay. So this is what we have to prove. This is what has been given to us, the first statement, x sin a plus y cos a is equal to z, x cos a plus y sin a is equal to question mark. We have to prove that. Now if you note here, there has been an interchange of sin and cos over here. So what we will do here is, we will take the first one statement and we will simply square both sides, okay. We'll simply square, so the z will also be squared. X square sin square a plus y square cos square a plus 2 xy sin a cos a, that is equal to z square, okay, that is equal to z square. Now what we'll do is x square, because I am seeing with the x now there is a cos, so I have to somehow get a cos over here. So 1 minus cos square a, 1 minus cos square a, okay, plus y square 1 minus sin square a for the same reason, but this one just copy, xy sin a cos a, just copy, that is equal to z square. Okay, so x square minus x square cos square a plus y square minus y square sin square a plus 2xy sin a cos a, that is equal to z square. Okay, now x square plus y square, this one copied, okay, and bring that z square from that side. I have taken that z square from that side, it has been brought, so there is a minus sign here. Take this x square cos square a, I have taken it to the other side of the equal to sign, so change in sign, plus y square sin square a, okay, minus 2xy sin a cos a. Okay, so I have now shifted the cos theta sin theta terms to the right and only variables this side. So here if you see a square b square minus 2ab, that gives me cos a minus y sin a and a whole square over here. Okay, sorry, this is by mistake I wrote plus, this has to be minus. Okay, so here now I have, if you see now, this is matching with this x cos a minus y sin a, it is matching. Okay, if I want to find the value of x cos a minus y sin a, I need to find a square root both sides. I have to find a square root both sides. So this is minus y, so write it without the square sign, and here x square plus y square minus z square plus minus. Okay, so we have finally, this is our final statement, this is our final answer, we have got it. So if it's an MCQ, please check for the correct signs, look for the plus minus sign, look for the minus sign over here. Okay, and when you bring it, you keep interchanging signs, see to it that you are very careful with the signs. Now this is a new question. Tan theta is a minus 1 by 4a, and what is the value of tan theta and sec theta? Now since we know only the value of tan theta, we want to get our value of sec theta also, so that we can subtract. So how to get that? So if I square tan square theta is sec square theta minus 1. Okay, so here tan square theta is, so tan square theta is this, according to here given, sec square theta minus 1. Then what do we do? A square plus 1 by 16a minus 2 into a into 1 by 4a, that is a plus b whole square. This is the 2ab term, and here it is sec square theta minus 1. Okay, so what we'll do here is, we'll first cancel as far as possible. So a square plus 1 by 16a, and then comes the, here there is a minus 1. Okay, here there is a minus half, and from that side it is minus half plus 1 is sec square theta. So this makes a plus half. Okay, a square plus 1 by 16a plus half is equal to sec square theta. If we are getting this, this becomes a, what does it become now? It becomes a plus 1 by 4a whole square, isn't it? It makes a plus 1 by 4a whole square. Why? Because the 2ab term will reduce to a half. Okay, if you want to see why the 2ab term reduces to a half, 2 into a into 1 by 4a, this, see, the 2ab term is a half. Okay, that is equal to now sec square theta, that is equal to a sec square theta. So sec theta is equal to plus minus, okay, a plus 1 by 4a plus minus a by a plus 1 by 4a. Okay, so here I have two values of sec theta, not just one, because we have done square root, plus and minus. We are going to use them separately and get two answers for this question. Remember, this question will have two answers. We'll just leave that over there, and now I'm going to substitute over here. So here this is a minus 1 by 4a. For this tan theta, I just substituted this value. Now for the sec theta, I am going to take the plus 1 first, a plus 1 by 4a. Yeah, I have taken the plus 1 from there, a plus 1 by 4a I have picked up. So that is equal to how much? A minus 1 by 4a minus a plus minus a plus minus a minus, again minus a minus 1 by 4a. This cancels, minus 2 by 4a, that is minus this. Okay, let me come to the next one where I am going to use the minus 1 of the sec theta value. So a minus 1 by 4a. Okay, so this is again tan theta minus sec theta happening all the time. Okay, don't lose track. Tan theta minus sec theta happening. Okay, so that is equal to, this is tan theta written. Now the formula has one minus, the expression has one minus, and the value of sec theta has another minus, so it becomes a plus, a plus 1 by 4a. Okay, and that becomes a minus 1 by 4a plus a plus 1 by 4a. This is gone, so that is a 2a. Okay, so this is the answer of the, so here is one answer of tan theta minus sec theta. Okay, and here is the second answer of tan theta minus sec theta. Okay, so these are the two answers of tan theta minus sec theta. So here is our next question. This is a girl, Sonali, who is standing here. There are two light poles here. This is a road. Okay, they have told this is a road. She is not on the road, she is beside the road. She is standing at a distance of p from the road, and these angles have been told to us as a 90 degree. Here there is a pole, light pole 1 and light pole 2. The distance between the two poles is a d. Three options have been provided to us, A, B and C. We have to choose the correct answer. And here they are saying that this distance is an r, here to here is an r. Okay, we can even name it as a PQ. And here Sonali, let's say this is an r, the point where Sonali is standing, let me name it as an r. So here r to p is a small p. We have to choose between the three options for what? Distance d. Which of them represents d? Okay, out of these three. Let's start. Now here if this angle is 90 and this angle is 90, that means corresponding angles are equal, lines are parallel. Okay, so we are going to try to find an expression for d. As I said, if lines are parallel, the triangle PQR, is being, the width of the road has also told to be a 7. Now if, as I said, these two lines are parallel, now since we can see that this line is parallel to this, we will be proving similarity between this small triangle and the big one. So how to prove similarity? In triangle PQR and triangle, let's take ABR, isn't it? ABR. Just two triangles, if we prove they are equal, then the triangles will be similar. Angle QPR, this 90 degree, is equal to angle BAR given. Okay, so we have proved equal for one of the angles. Let's come to the second angle, which is angle A, let's say PRQ, that is this angle, is equal to angle ARQ, same angle. Okay, it's the common angle. Okay, it is the common angle between the two triangles. Therefore, triangle PQR is similar to triangle ABR. Once similarity has been established, we know that the ratio of the sides are equal. Okay, so now we are going to show that the ratios of the sides are equal, and remember one thing, we are definitely going to include this distance d because we want an expression for it. So we can take d by r for the small triangle, sorry, d by small r, okay, and that is equal to, now if we take this side of the triangle, it is, for the big triangle it is p plus 7, for the small triangle it is a p. So d is equal to r into p plus 7 by p. Okay, so for us the C expression is the correct expression. So D gives us the formula for the expression for the distance between the two poles. Okay, so if we are getting a sum like this, remember one thing where the mistakes happen. The moment we see parallel, we start working with the sum. Okay, either we start applying BPT or we apply whatever ratios, but then what we have to be very sure about is we must prove similarity first, because they have only given us parallel lines. That does not establish similarity. If you are using BPT for some, in this sum I could not apply BPT because it is taking the base. You see, it is taking the base. BPT does not talk about the base. Okay, it does not talk about the two parallel lines, it talks only about the sides. So if I have to talk, because I had to include the base because I had D there, so I had to go for regular similarity. And when you are going for regular similarity, see to it that you are always establishing similarity in just 2 steps, takes just 2 steps. Okay, in just 2 steps establish similarity and then proceed with the ratio equal part of it. Okay, without that you should not come straight to this part. Okay, here is a very big sum, subjective type, but it isn't that tough, I'll tell you. First thing, I've split down the question for you all just to make it a little easy. The circular path is 800 meters. Yeah, this is the circular path which is 800 meters, total length of the path. There are two girls, Kimaya and Hina. They are starting from here at the same time. Okay, and Kimaya's speed has been given as 100 meters per minute. Now note the units, they are both meters per minute. Here Hina's speed is 80 meters per minute. So Kimaya is moving towards the clubhouse and Hina is moving towards the badminton court. Okay, she is moving towards the badminton court. These are the two destinations. Okay, let us understand the figure first. So this is how they have given it in the question paper. I have not drawn. Now, so both the speeds are given and I have written them here. Total length is 800. Hina took 1 more minute than Kimaya to reach the badminton court. Now Hina's destination was the badminton court. She took 1 minute more than what Kimaya took. Anyway, she is going at a slower speed, and then there is these distances are also not equal. Now Hina has to reach the badminton. Now find the time taken by Hina to reach the badminton courts. The only one condition that has been provided to us is that this girl takes 1 more minute to reach here than what this one takes to reach the clubhouse. Okay, how much time does she take to reach the badminton court? Okay, so I think I have told everything. I'll repeat. Total is 800, speed here is 100, speed here is 80, but per minute, meters per minute. Okay, this one takes 1 more minute than this one to reach her destination, and between the clubhouse to the badminton court there is a distance of 180 meters. That is also told in the question. So let us start with the question. So this is our diagram now. Now here if I take time taken by, let me take the distance travelled, okay, distance starting from P to the badminton court, if I take it as an x, okay, and here now 180 is already subtracted from 800 because total was 800. Subtract 180, you get a 620. 620 is the sum of this and this. Okay, now here this side is an x. Okay, if I take, this is not 100, this is 100 meters per minute, don't confuse between, and this is 80 meters per minute. This is a speed. Now we are talking about distance. Now here this is 100 is going to be now this distance is how much? 180 has been subtracted, so we are left with a 620. From 620 take out an x, so you have how much now here? 620 minus x is p to the clubhouse, isn't it? So that is 620 minus x. Now I am going to form the equation. Here everything is in meters per minute, so my equation will also be in minutes. So here it is, say distance by speed is equal to time. I am going to use this formula. Okay, so here it is x by 80. Why x by 80? Because that is the time Hina took to reach the badminton court, and it is one more than what Kimaya took, minus. Okay, if you take out this one's time, 620 minus x by now 100. Okay, that is equal to 1. So this is an equation which we have got using the two distances. So the trick here is to understand this is 620 minus x, and always what is wanted, it is better to take it as an x, you go faster then. Okay, distance by speed, both at times we have subtracted, we have got 1. Since it was already meters per minute, our answer is also going to come in minutes, so no problem. Okay, if it was in kilometers per hour we have to think. Okay, but since this is in meters per minute only, so we can proceed with the question. So here the LCM is a 400 for 800 and 100. The LCM is going to be a 400, isn't it? So LCM is a 400. Now this becomes a 5x minus, this is 620 into 4 and minus into minus plus 4x. Okay, so that is equal to 1. Okay, so now we are going to proceed another step. 9x minus, if we multiply we get a 2480, that is equal to 400, isn't it? Okay, so this equation is not even a quadratic equation, it is a complete linear equation. So let us complete the sum over here. So 9x becomes 2480 plus 400, that gives me how much? 2880. X is 2880